Good morning everybody and welcome to this webinar on Spectralink DECT solutions. Today we will be discussing LAN-based radio synchronization, which is not so much a feature as a whole new way of managing synchronization, which is critical in a multi-cell DECT solution. My name is Chris Pulsford and I'm the National Partner Enablement Manager for Wavelink. So just to touch on some of the key points that we'll be discussing today in relation to this feature, which will benefit not only yourselves as resellers, but also your customers, because it does give us a much greater flexibility in deploying DECT systems and also some other benefits such as introducing additional reliability. The key points we really want to focus on for this webinar are around simplified system deployment, and obviously that's important for us as resellers if we can do things more easily. Potentially reducing the number of base stations that we can deploy. We'll look at how we can do that as well, and that can lead to things like potentially at lower cost for the solution, which may help drive some sales opportunities. And then also want to have a good look at how this new methodology works and what are some of the considerations that we need to think about and make sure we have in place when planning a deployment using this new LAN synchronization option that we have. This specifically applies to IP DECT base stations. So some of you may have historically done digital base stations only. Some of you may have done IP DECT base stations only, and some of you may have done both. It's quite possible that if you've only done digital base stations in the past, it may be because there are some benefits to the way you deploy those base stations compared to IP DECT. What we'll be looking at today really brings IP base stations into alignment with that, because there are actually a lot of benefits in running IP DECT base stations over digital. So there's benefits to both of those. But realistically, the IP base stations can be used on any of the current model Spectralink DECT servers. So that's not just limited to what we term the IP DECT solutions, which would be the IP DECT server 400 and IP DECT server 6500, but that also applies to the DECT server 2500 and DECT server 8000, where historically most people have run digital base stations, or what Spectralink just call their DECT base station, but can definitely now run IP base stations on all of those systems. So this is relevant regardless of whether you've only ever done IP DECT or if you've done, I guess, what we'd probably call more traditional DECT solution. So let's just start by having a look at some of the benefits of using IP base stations, because this is quite relevant when you consider now that we can deploy IP base stations in a similar sort of methodology, not exactly the same, but in some ways quite similar to how we've traditionally done digital base stations. So one of the key benefits of a IP base station over a digital base station is that they support 12 voice channels per base, and this compares to what's historically been 4 channels on a digital base station, but you can now have 8-channel digital base stations. However, if you use an 8-channel digital base, you're actually using twice the amount of pairs on your wiring, and as a result using twice the amount of interfaces on your base station interface card. So if you're using the 8-channel digital bases, there is a cost, a real cost in terms of probably having to add additional base station interface cards. So if we can run 12 voice channels per base, that's obviously a big benefit to us. We can run these off PoE switching infrastructure. These days it's very common for organisations to have deployed PoE switching or power over Ethernet switching, which can not only provide the communications to the devices hooked up to that switch, but also power those devices. So the original PoE standard 802.3 AF is compliant with the Spectralink IP bases, and anyone who has a compatible PoE switch, which will be just about any PoE switch will support AF, it's the original standard, and the lower power of the two standards will be able to run IP base stations. The IP base station supports external antenna for extended coverage, so if you had to throw what is, without the antenna, a spherical shaped signal in a more directional way, or get a signal into an area that's difficult to do so because of cabling restrictions, then you can have an option to hook up an external antenna to an IP DECT base station and make use of that extended coverage. Auto discovery from server. So you can actually connect your IP base stations into the switch, and if they're on the same network segment as the DECT server can actually detect and discover those IP base stations, and that makes our life as a administrator configuring that system a lot more easy, because we don't have to go into each base and program them up without, or have to find them first. We can just do that directly from the server. Makes things a lot quicker. Okay, we can utilize the customer's existing LAN switching, so their Ethernet switches, etc., which these days they'll typically be running for all their IT needs anyways. So we're simply tapping into that switched environment and not having to run a duplicate wiring infrastructure as we would be if we were running digital base stations. So we might as well utilize their existing infrastructure, and certainly if it's a new site, a greenfield site, it's highly likely that the customer will just want to deploy sort of the Cat5e, Cat6 cabling and use that for all their needs, rather than deploy a separate infrastructure on top of that to do something like DECT. So that gives us another benefit. Also a lot neater. We don't have to use punch down blocks to wire in our digital base stations with IP base stations. It's just an RJ45 at each end, straight through cabling, Cat5e as we said, or Cat6, and gives us a lot quicker and also neater solution there. And that basically means it's easier to deploy initially, and also we can add more bases as required without too much trouble. Another thing it gives us the potential to do with IP DECT base stations is have multiple sites. So we might have, let's say, a head office with a DECT server and some IP base stations for coverage there, but we also might have some branch offices that run DECT handsets, and those base stations at those remote sites can connect back through the DECT server via a WAN link and provide coverage at the branch locations, and we don't then have to deploy a DECT server at each site. So obviously that's a cost benefit for the customer, and this isn't something that you can do with digital base stations, because a digital base station actually has a one-to-one direct connection to the base station interface card in the DECT server, and we can't do that across multiple sites. So you can see that there's quite a few benefits of running IP base stations over the digital base stations, and I guess this is all relevant given what we're looking at today, so I just wanted to touch on some of that as a starting point. Also worth pointing out that if you've got a DECT server 2500 or 8000, you can also run a mix of IP base stations and digital base stations as well, so that just gives us greater flexibility. In a multi-cell DECT system, it's critical that you have synchronization. So all the base stations in a multi-cell DECT system have to be synchronized to each other, and this facilitates handover. So if a user is on a call, or even if they're not on a call, obviously the handset needs to stay in communication with the DECT infrastructure. So having the synchronization there allows them to move about the facility and have the handset hand over between the different base stations to maintain correct coverage and correct signal and all that type of thing. So when they do need to make a call or receive a call, they can do that. And also, if they're on a call and let's say they're handing off from base station A, which they're currently on, which may be on, let's say, quite a long cable run, and they're handing over to base station B because they're moving in that direction, base station B may be on a much shorter cable run, then when they hand over, the system will also use that synchronization to insert the appropriate amount of delay into the call during that handover process to make sure that the users on the phone have a smooth handover experience, and actually won't be able to tell that it's handed over because there's no interruption or distortion of the audio stream during that handover. So in IP DECT base stations, traditionally what we've had to do is synchronize these over the air, and that means using one of our 12 voice channels on the IP DECT base stations to maintain a synchronization state with the other base stations. So we cut back to 11 channels, and we're managing this over the air, and that's in direct comparison to digital DECT, where we've done that over the wiring in the past. So we've got a user, obviously they're talking to a base station, or they're communicating with a base station while they're on the DECT call. As they move throughout the facility, their handset will hand over between the different base stations as required. However, the base stations always maintain this synchronization state to facilitate that activity. So just having a look at how that has happened historically, as we said, digital base stations have a direct connection to the interface card in the DECT server, and the DECT server manages that directly over the wire. So, that means we've got a reliable connection because it's a wired connection. The base station's always in direct contact with the DECT server, and the DECT server can manage that process directly. With IP DECT base stations, historically there hasn't been an effective method to support synchronization over the wired infrastructure. It's a very time-sensitive requirement and just hasn't been possible previously over an Ethernet LAN or local area network. So we had to synchronize over the air using the RF capability of the radios in the base stations. If you look at the picture on the right there, just to really quickly explain how that works, there's a master radio, which is one of the base stations in the synchronization chain in an IP DECT solution, and all the other base stations, either directly or via an intermediate base station, need to synchronize back to that master base station to maintain synchronization. That master base station essentially is the master clock for the synchronization chain there. If you look at the arrows, the green arrows indicate a primary sync source. So for each base station you have to specify a primary sync source and a secondary sync source. So if a base station is located adjacent to other base stations in such a way that it can have enough signal overlap to not only support a primary sync source, as indicated by the green arrow there, it can also have an alternative sync source as an alternative path back to the master base. If the primary sync source is lost, then we can also set that as a bit of redundancy. If you look at the base in the top right-hand corner, it doesn't have any other adjacent bases to synchronize via to get back to the master base, so it has to set its primary and secondary sync source to an intermediate base. So what's the issue with this, or one of the, I suppose, the vulnerabilities of this, is that if a base station in that synchronization chain goes down for some reason, now that could be for a number of reasons. Maybe there's an issue with the cabling or the cable. Maybe there's something wrong with the switch port that it's connected to, the PoE switch port. Maybe there's something wrong with the base station itself, and that goes off the air. Any other base stations that use that downed base to connect back to the master will actually lose synchronization, and as a result, any user on that base station that's down, or any other base station that's using that as a sync source, if it doesn't have an alternative path back to the master, users on that base or bases will not be able to make or receive calls, and certainly won't be able to do a handoff either. So that's a big issue for us. If the master base itself were to go down, then every other base station in the synchronization chain would lose synchronization, and as a result the whole system effectively falls over as far as being able to support phone calls on the DECT system until someone actually comes in, a technician, and replaces that down base station, and then also has to manually do some reconfiguration of the synchronization chain to bring that synchronization chain back up and then get the system working again. So you can see how that's quite vulnerable in certain ways as compared to what the digital base stations do. If a digital base station goes down, the area that it provides coverage to will lose coverage and ability to make and receive calls, but all the other base stations are independent of that as far as synchronization is concerned and won't be affected. Configuring an over-the-air synchronization chain also is traditionally been the most difficult or complex part of configuring an IP DECT solution or a solution using IP DECT base stations. Because we're actually having to use that over-the-air synchronization, it means a couple of things. It means, first of all, we have to take a lot more care when we do our site survey to ensure that our layouts are correct, our placement is correct, and hopefully we can work in a layout in such a way that we can have not only a primary sync source but also a secondary sync source for the base stations there to find their way back to the master. And then we need to use that information and configure each of the IP base stations individually and point them at their sync sources. So if you look at the little smaller insert picture on the bottom left-hand side of the screen, that's the configuration page of one of the IP DECT base stations that would be in the solution on the plan here. And we can see in the red circle there how it sees the adjacent base stations in terms of signal strength. So we use that information as well as what we've got from our site survey there, and we'd actually go in under the synchronization section of that base station configuration, and we would set both the primary radio sync and a secondary radio sync as the RPN or radio part numbers of the other base stations in the system, or the base station that we're going to actually use to synchronize base station number 2. So if we had the option, we could synchronize, let's say, RPN 0 as our primary sync source and RPN 1 as our secondary sync source, or if we only had one other base to synchronize via, because that's all our coverage allowed for, we simply put that base station as both the primary and secondary sync source. What we have to do, though, is we have to go to every individual IP DECT base station in the system and program that up manually. So you can imagine that takes quite a bit of time, configuration time and effort to do that. And that's, as I said, typically the most time-consuming part of configuring a DECT server that uses IP base stations. The other thing is, because of the dynamic nature of radio frequency, or RF, and the constantly changing RF environment, the signal strength and quality will always vary literally from one minute to the next based on things like objects moving through the environment, or people or equipment reflecting and absorbing the signal. So unlike a direct wire, as we have with digital DECT, managing that synchronization, we've got a constantly changing RF environment, and we're relying on that constantly changing environment to support our synchronization chain. So, for example, in a manufacturing environment, we might have a lot of heavy moving equipment, might be gantries rolling around, there might be phase 3 power that's coming on and off intermittently, causing some EMI or RFI. We might have a loading dock where trucks are coming and parking, and when they park in there, that's obviously going to alter the RF environment. So all of those things which can impact the RF environment, as a result, can also impact on the integrity and reliability of our synchronization chain if we're going over the air. Even things like a lot of people in a certain area. Maybe you've got a big function on one day in your business. All those people can also have an impact on the environment of the RF because they're absorbing and reflecting signal as well. So all those things really need to be taken into consideration when we're talking about doing over-the-air synchronization. As a result of that, when we're doing an over-the-air synchronization with an IP DECT base station setup, there's two types of overlaps that we need to take into consideration. One of those is our synchronization overlap, and that basically is to ensure that our synchronization chains are reliable and robust. And to do that, we have to make sure we have a 50% overlap between our IP base stations. Now, essentially what that means is, if you look at the picture with the base stations, the circles around those represent the acceptable boundary of that coverage. So typically we'd be looking at RSSI, relative signal strength indication, keeping that around 75 for this reading here, and then making sure that our adjacent base station will actually be overlapped by that coverage. Okay, and this is again to ensure our synchronization chain is robust. So this is our synchronization overlap. So you can see that's quite a big overlap there, 50%, but that's what's required. So, and this is where if we have issues, or we've seen issues on systems using IP DECT base stations, then typically it's because the installer hasn't put enough overlap between the base stations, and as a result, the synchronization chain is unreliable or weak. Okay, so that's how it's done traditionally. Let's have a look at what we can do now, because Spectralink have just released a license-based option for synchronizing via the local area network, or the LAN, so via the wired cabling infrastructure. So there's a number of benefits to doing it this way, and some of those are probably already obvious based on what we've discussed so far, but we'll go into those in greater detail and have a look what this means for us. So first of all, because we're no longer relying on over-the-air synchronization, we can place the base stations further apart. Okay, so we're basically moved right away from synchronizing over the air, and we're now synchronizing over the wired infrastructure. So you can see already it's got a similar type of methodology to the digital base stations, even though it is different type of media that we're connecting via and different type of methodology, but we're not using the radios in the base stations anymore to do that synchronization. So let's just quickly recap. When we did over-the-air synchronization, we had to have a 50% overlap between our base station signals to ensure reliable synchronization chain. Once we go to synchronization via the LAN, we only need to have a 10 to 15, I always say 15 to ensure a little bit more safety factor, a 15-meter overlap between the base stations. So again, the circles around the bases represent the acceptable coverage limit from that base station, but instead of having to overlap that completely onto the adjacent base stations, we simply need to make sure that we've got a 15-meter overlap of the two cells of coverage there to ensure correct handover for the user's handsets as they move throughout the facility. So whereas with over-the-air synchronization we needed both a synchronization overlap and a handover overlap, once we go to this type of methodology, syncing via the LAN, we only need to have a handover overlap, and that's the same as for digital base stations. So the overlap in this situation now is all about ensuring that a user on a handset can move throughout the facility, and as they move from the coverage area of base station A to the coverage area of base station B, there's enough overlap between those bases to give the handset time to complete the handover process. And essentially that's roughly calculated based on the average walking speed of a person. So your 15 meters is a safe bet for most environments. You know, if they're using DECT handsets on something like forklifts in warehouse while they're driving around, which is probably not really compliant with OHS anyway, but obviously they're going faster, then you'd need to put more overlap. But essentially what we're saying here, the main point being, is that now we can have the same overlap between our IP bases as we've traditionally had and still have, obviously, with our digital DECT base stations. Another benefit, the configuration is much simpler because most synchronization chains need to be manually configured and maintained. So, you know, as we said in the previous slide there, for each IP base station, when we do over-the-air synchronization, we need to go into that base station and work out our programming details in terms of pointing it back towards its master base station. So it's a very manual process and not something that we need to consider if we move towards this LAN-based synchronization. Synchronization is self-healing because if a base station does fail, then that doesn't directly impact on the synchronization chain. It will impact obviously on the area of coverage that it provides, because if it's off the air effectively, then it won't provide a footprint of coverage that users can use to make and receive phone calls, but it only impacts that area of coverage. All the other base stations can keep working and operate as normal. And there is a self-healing aspect because, as we'll see in a few slides' time, the system actually recalculates its synchronization chain if that happens and new adjacencies are formed or synchronization paths are formed automatically, so we don't have to worry about doing that. Whereas if it was over the air, we'd have to go back and manually reconfigure things. Another nice feature which is related, LAN synchronization, is administrated centrally. So the synchronization is just a matter of going into the DECT server. The upper left-hand screenshot there shows a page in the configuration of the IP DECT server, and you just simply select the type of default sync that you want to run there. So you can see you've got radio or LAN, or free running as well if it was just a single base station. So if we select LAN there, we're setting that to be the default synchronization type. Radio would be for over-the-air sync. And if you want to see that option there, you need to have the synchronization license applied to the system. Otherwise, you simply wouldn't see that in the option list. The screenshot on the upper right-hand side is basically one we looked at previously. We don't need to worry about that anymore. All we would do is go into the base station, and in the type box under synchronization, we'd set that to LAN, but that's it. We leave it at that. And then down the bottom there, we can see just a status shot of the base stations, the IP base stations from the DECT server, and we can see that the sync source is set to LAN. But also under sync, we can see base station number 0 is effectively the sync master. Even though it's not over there, there's still a sync master. And the other base stations, just with the green tick there, are in a synchronization state. So we do have a healthy working system there. Okay, despite the fact that the DECT server is where you configure the synchronization type, the actual synchronization process is handled autonomously by the base stations themselves. So the server doesn't actually play a part in that, and that means we don't actually need to have the DECT server on the same network segment. So again, if we come back to our scenario of multi-site, we have a DECT server at one site, we have other branch sites that just have IP DECT base stations for coverage. They will all have, each of those sites will all have their base stations working out the synchronization chain between them on each of the sites as independent little systems, not requiring the DECT server to manage that. Okay, so how does it work? So it uses Precision Time Protocol version 2 or PTP version 2, and that's what is used to synchronize the DECT radios via the LAN. So this is a IEEE standard, which is the Institute of Electrical and Electronic Engineers, I believe it is. So it's a ratified standard from the IEEE. PTPv2 is based on a master-slave architecture, so the active master, which will be the master base station, is automatically selected among the base stations. So there is a metric that they use to work that out between each other, and then they appoint the master base station. So, you know, we looked at what happens if a master base goes off the air in an over-the-air scenario, that all the base stations will lose synchronization. If even the master were to go off the air in this type of methodology, then the base stations between them would simply you know, run their algorithms and work out, based on the result, who will be appointed as the new master, and just go from there. Each network segment will have one active master and the remaining base stations will be slaves. So again, whether that's the single site or a multi-site solution or deployment, that will happen on each of the sites. And realistically, you know, that is still similar to how it would be with over-the-air sync, but again, the difference being that we don't need to manually configure that. And the current synchronization state isn't disturbed or disrupted when that base station goes down. So it doesn't have an impact as far as the user is concerned, and I guess, you know, that comes back to the self-healing aspect that we mentioned in a previous slide there. So what are some of the requirements that we need to have to run this solution? Okay, well, first of all, we need to have all our base stations, which are IP base stations obviously, and the DECT server running a recent version of firmware, which would be PCS 15C or something after that. So I think at this stage 15C is still the latest version. However, you know, all you need to do if you want to run this and you have an older version running is go to Spectralink support site and download and update your systems to 15C. So that's both the bases and the DECT server. We also need to have the license. So this is a license-based feature. LAN synchronization license needs to be on the system to support this, and we'll talk a little bit about that in a few slides' time as well. PTP uses or relies on the network supporting quite strict, you know, time management. So we need to have multicast. It uses multicast traffic, and so to support that, the timing of the network needs to be good. So we can't have too much delay, we can't have too much jitter. That will affect the operation and potentially, you know, mean that if you've got non-managed switches, just sort of cheap low-end switches, it may not be an option, because, you know, we need to have switches, and we'd always recommend using enterprise switches so you can make sure that your timing or those switches can manage the traffic in such a way it's not going to introduce you know, a lot of delay or jitter and those sort of things which could impact on the operation of that LAN synchronization and the precision time protocol, which uses a multicast methodology. So as it says here, it does use multicast packets. So, and with precision time protocol, the multicast packets can't traverse routers, so they have to stay on your local network segment. Okay, so basically we want to have some sort of methodology or mechanism to manage the multicast traffic. So the switches must allow multicast traffic to and from all the base stations, and There's a number of ways you can handle multicast traffic on a switch. One thing you don't want to do is have a non-managed switch or an unmanaged switch, because they can't handle multicast traffic, or they can't manage it. So basically, they would just treat it as broadcast traffic and send the traffic at every port on the switch through every transmission, even when some of those ports will be connected to devices that have absolutely nothing to do with the multicast traffic in question. For example, you might have a mixture of base stations, PCs, printer, and other devices on your network switch, and all you want to do is have this PTP multicast traffic going between the base stations and the DECT server. Okay, so you want to make sure you can manage that. The most common way that this is done is with IGMP snooping, which is Internet Group Management Protocol, and essentially that's a feature on pretty much any managed switch, which means that the switch can intelligently learn which devices connected to the switch using multicasts, and basically then only send that multicast traffic to those devices that require it and are actually involved in that multicast exchange of traffic. So it limits the amount of traffic going over the network, it eliminates unnecessary traffic going over the network, and it can dynamically learn if a new device is connected or a device that was connected leaves the switch, and it won't continue to send that multicast traffic around those ports. So any layer 2 managed switch should support IGMP snooping. So again, you really want to make sure that you have a enterprise or a managed layer 2 switch, and it doesn't mean an expensive switch. There's a lot of managed switches that will do, IGMP snooping is a standard managed feature of switch, and it also means you're going to have less issues regarding timing. They'll forward the traffic a lot quicker, less delay, reduces the likelihood of jitter being involved, and also lets you do things like VLAN tagging. So obviously, if you're running voice and data off a switch, you want to make sure that you're prioritizing your voice traffic, so you can also use the VLAN features of managed switches. So there's a whole range of reasons why you'd want to be using managed switches for this type of thing, but certainly in relation to this, the IGMP snooping feature. So it brings us to timing and jitter. As we said, for PTP to be accurate enough to synchronize the DECT radios and manage that through that multicast traffic, the network jitter has to be low. Okay, so jitter, just to define jitter, obviously in a packet switch network there's always going to be delays between packets going from their source to their destination. They may even take different paths through the network. So jitter is when those packets have different lengths of delay between their destination or their source and their destination. So packets will arrive with different amounts of delay between them, and that's defined as jitter. So if there's an excessive amount of jitter on the network, then that will have an impact on how this works. So we want to have the packet delay between the packets going from the source to their destination as a fairly constant amount of delay between them. The PTP have built-in filtering, so it does allow them to cope with some level of jitter. You're always going to get jitter on a network. It's about minimizing that jitter. So that'll be impacted by things like network topology, how many devices are on the network in terms of devices that will process the traffic, switches, etc. The traffic patterns on the network, is it a congestion? We have VLANs running to, split those broadcast domains. The quality and configuration of the switches, obviously we've talked about that last point quite a bit already. All those things can have an impact. Every base station has the capability to become a master or slave regardless of its position in the network topology. So again, that's something that will be dynamically worked out between the base stations there. You need to consider the placement or the position of the master slave when deploying the bases. As it says, any base station can become a master or slave, but you want to make sure there's not too many forwarding points in the traffic path between the master and the slave bases, which could introduce things like the jitter and the delay that, as we said, can impact on how this works. So if you look at this particular picture here, you'll see there's 3 switches between the master and the slave. In the lab, Spectralink have done the testing, and they've been successful in having up to 5 switches between the master and slave base stations. So I think that'll cover quite a large site, multi-story site with a number of IDFs. So that should be fine for pretty much any customer site that you have in a practical sense. Okay, let's have a look at the cost factor. How does this impact on cost? Because it certainly can have a big impact, and the amount of impact that it will have will scale with the size of the systems that you want to deploy. So first of all, I guess we should mention that the cost of an IP DECT base station is approximately $1,400. So it's not a cheap device. And yes, it is more expensive than a digital base station, but as we said at the start, there's a number of reasons why an IP DECT base station we could say is better than a digital base station, not in what it does in terms of the quality of the calls it supports, but in some of the other benefits that we can have there. So if we're deploying, like we said, compared to over the air, we're deploying a fewer number of base stations as a result of us being able to put a bigger spacing between those base stations or IP base stations. We don't need as big an overlap. So that will mean on anything other than quite a small site, it'll mean we can actually deploy less base stations to cover the same size area. Okay, so obviously that will mean as the size of the site and the deployment increases, then we can save more money because we'll be able to drop more base stations as that scales up. So from a cost point of view, the licenses that the license that you need to support this sync over LAN feature depends on the putting it on. So for, I guess, the smaller system in both the IP DECT range and the standard DECT range, which is the 400 and the 2500, $1,321 RRP. And for the larger systems, it's a shade over $2,000. Okay, so keep that pricing in mind along with the pricing of the IP base station itself. Let's have just a look at one example of how that might look in a real-world environment. So here we've got our IP DECT server 6500, and that's costing us $2,354. This is retail pricing. We have 20 IP base stations at $1,400 a pop, and we're doing over-the-air synchronization. So our total system cost is about $30,000 plus. Let's say we change that. Now we move to putting a LAN sync license on that, and that's going to add $2,172. But because we're now syncing over the LAN, we can actually drop or reduce the number of IP base stations we're deploying. So we've gone from 20 to 15 IP base stations. So we're saving 5 times $1,400. Yes, we're adding a license worth a couple of grand on there, but our total cost now has come down to $25,500, giving us a potential saving there of just under $5,000 by using LAN sync as compared to over-the-air synchronization there. Now, generally as a rule of thumb, we'd probably say use approximately 30% less base stations if you're placing them for LAN synchronization or digital DECT as compared to over-the-air sync with IP DECT. So even that's been a bit conservative because we just dropped 25% of our bases. So it actually might be slightly bigger saving there. And keep in mind here, all we've talked about here is the actual cost of the product. If we're deploying 5 less bases, it means we're doing a lot less cabling. We're not having to do 5 additional cable runs. They might be into areas that are tricky to do, might be cost involved in that. We're obviously saving the time component of running those cables, and we're also saving the time component in the configuration of the DECT system because we no longer need to do that over-the-air synchronization configuration of all the IP DECT base stations. So the actual cost will be quite a bit more than that $5,000 of hardware. It extends to all those other things as well, so just keep that in mind. Okay, so just to wrap up, I think we've covered off all the key points there. Obviously, there's a lot more granular stuff if you want to read into that, and there is a white paper on Spectralink support site which will give you all the details of that if you want to know more. But realistically, the key points I guess we'll take away from the webinar here are we've got a more robust and redundant DECT system. We're not vulnerable to either a base station going off the air that is providing sync to other base stations, or even maybe the master base station going off the air, which will impact the entire system and bring that down. So we've got a more robust and redundant DECT system, and realistically, you could say it's more or less as robust now as a digital DECT solution because we're going over the wire. Yes, there'll be more points of failure potentially because it's still an Ethernet LAN. There might be multiple switches that could have points of failure, but it is much closer now to a traditional DECT system than how it was when using over-the-air sync. Simplify deployment and configuration, as we said, both in running less cables, how much configuration we need to do on the actual system itself. So that'll be much simplified as well. And also means, not that we'd recommend it, obviously you always want to always make sure you're taking your due diligence in the site survey stage, but I guess there's less potential for things to go wrong based on your base station location and placement than there is with over-the-air sync. So it should simplify the whole process from start to finish. And then the cost savings as a result of the simplified deployment and configuration, and also the potential to reduce the amount of infrastructure you need to cover an equivalent size area. Okay, so that's the main presentation that I wanted to share with you guys. We do have a option for you to ask questions. If you do, there's a question box which should be in your little GoToWebinar control panel. Feel free to type out a question if you have that, and I will attempt to answer that for you. I've got a couple of questions that I'll read out now. The first one is, what is required to run IP bases on an 8000? Well, as we said, IP base stations can certainly run on any of the DECT servers. If you're running it on an 8000, where, with digital base stations, you have a base station interface card which directly connects to those, or to the wiring for the bases. If you run IP bases, it actually uses the VoIP interface card to support IP bases on an 8000 or a 2500. So you don't need to run base station interface cards anymore. If you wanted to put IP bases on an 8000, you will need to have a VoIP interface card on the system. And that VoIP interface card historically has been used to support SIP extensions off an IP PBX when you integrate that with the DECT server, but that same card also supports digital base stations. So that card will manage the RTP streams, or the media streams, between both an IP PBX and the DECT server, if you're running SIP extensions, or also the IP base stations and the DECT server. There's no reason why you can't run analog extensions on 8000 and use IP bases. You can pretty much slice and dice any way you want. You could use SIP extensions and IP bases, SIP extensions and digital bases, analog extensions with either type of base as well. Or you could mix, IP bases and digital bases. So there's just a whole lot of flexibility you can do running IP bases on an 8000. We've got a second question here. Do I need to configure the switches? Okay, so your network switches, as we said, first of all, you need to have managed switches with the managed features such as the IGMP snooping to support or maximize the management of that multicast traffic. And as we said, you can do other things like VLAN, a whole heap of stuff actually. But in terms of configuring the switches, all you need to do as far as this feature is concerned that we've been talking about today is make sure that IGMP snooping is enabled on the switch. Typically on a managed switch that will be disabled, but it's usually just a tick box or a radio button to enable that feature on the switch, and then that switch will start intelligently learning about the devices that are using the multicast traffic around the switch, and only make sure that it's sending that multicast traffic to ports connected to those devices. So it's a much more managed way to run that multicast traffic on the network. Okay, don't have any more questions here, so just want to quickly point out how you can contact us. If you wanted to know more, as I said, I'd start with going to support.spectralink.com. They've got a great wealth of information and resources on that site, everything from your software to your administrator guides, user guides, and white papers such as the one that describes this process in a lot more detail than we've looked at today. So please have a look at that if you're interested. And also, obviously, you can always call us at Wavelink or email us, whether that's sales@Wavelink or support@Wavelink, and we'll be certainly happy to discuss that feature further. Okay, so just want to thank everybody for coming. Hopefully it's been worthwhile for you, and hopefully this gives you an option to go and roll out some DECT servers with IP base stations. Thanks very much.